Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Representing, Naming, and Evaluating Functions. So the classwork opening exercise says to study the four representations of a function below. How are these representations alike, and how are they different? Okay, a lengthy explanation here. These representations are alike because they all match the same pairs of numbers. 0 to 1, input, output, 0 to 1, input, output, 0 to 1, input, output, and then the sequence, these are the functions anyhow. Okay, and they are different because they describe the domain, range, and correspondence differently. The table and the function look similar. The input and output are related to domain and range of a function. Evaluating the expression for the given x values returns the output values in the table. And the sequence also generates the output values for the first 6 terms starting at n equals 0. Okay? Okay, next page, exercise 1. Let x equal the set 0, 1, 2, 3, 4, 5. Complete the following table using the definition of f. So we're taking a function f and we're mapping all elements of x onto y. So x is 0, 1, 2, 3, 4, and 5 as stated in our set. And it says to assign each x, notice it's lowercase, that means each value in the set, which is capital. So each x, 0 is a little x in the big set x, to the expression 2 to the power of x. So in other words, for 0, that would be 2 to the 0. And anything to the 0 power is 1. And then 2 to the 1. So if I write these up right above, I didn't have much room for the first one. This is 2 to the 0. This is 2 to the 1. This is 2 squared. This is 2 cubed. This is 2 to the 4th, and this is 2 to the 5th. So 2 to the first power is 2. 2 squared is 4. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So those are f of x's that are elements in the set, capital Y. It says, what are f of 0, f of 1, f of 2, f of 3, f of 4, and f of 5? Okay, so f of 0, so this is f of x, and x is 0, so f of 0 equals what we ended up with when we plugged 0 in for x, and that is 1. F of 1 equals 2. F of 2 equals 4. F of 3 equals 2 cubed, or 8. F of 4 is 2 to the 4th, which is 16. And then finally, f of 5 equals 32. So all we did here was say that f of whatever equals, instead of just making a table like up here. Now it says, what is the range of f? Okay, well, x is the domain, and y will be the range, and the range of f is the set that include these values that we ended up with. 1, 2, 3, 4, not 3, 1, 2, 4, 8, 16, and 32. So that is the range. Okay, so exercise 2 says the squaring function is defined as follows. Let f, the function f, that maps x onto y, be the function such that x is being mapped onto x squared. Now let me just stop there and bring this in here. To signify the input-output relationship of x and f of x, students will write x and then this arrow f of x, which just really means that a value in the domain will be mapped onto the output f of x or y in the range. Okay? So they just use this arrow to say x is mapped to. The squaring function is defined as follows. Let the function f mapping x onto y be the function such that x gets mapped to x squared, where capital X is the set of all real numbers. What are f of 0? So I'm just going to show this. So I would say f of 0 equals, and 0 is my x, so I'm going to square it. F of 0 is 0 squared, which equals 0. Then f of 3. F of 3 is 3 squared, which is 9. Let me just change colors for each of these. F of negative 2 just simply means we're mapping negative 2 onto the function, which says to take negative 2 and square it. Be careful with negatives if you're using a calculator especially. We need parentheses. A negative squared is always going to give you a positive 4 in this case. So negative 2 squared is 4. And now we're at this one, f of the square root of 3, which equals the square root of 3 quantity squared, which equals 3. And then f of negative 2.5, which means negative 2.5 squared, which is positive. Negative times negative is positive, and 2.5 squared is 6.25. F of 2/3. Hopefully you remember from prior classes that when you square a fraction, you're squaring the numerator and denominator. This gets distributed, so it's 2 squared divided by 3 squared. Okay, and then f of a. Well, f of a is going to be a squared, whatever a is. Okay. And finally, f of 3 plus a. This one we need to be careful. This is a binomial. And when you square a binomial, you don't just square each term. F of 3 plus a means 3 plus a quantity squared, which means what's in the parentheses gets multiplied by itself. So that means 3 plus a times 3 plus a. And we distribute repeatedly, that some people call FOIL. So 3 times 3 is 9. 3 times a is 3a, plus a times 3, which is also 3a, plus a times a, which is a squared. So this simplified is going to equal 9. Combining like terms, our two middle terms always get added together. 6a, they're always like terms, plus a squared. So f of 3 plus a is not 9 plus a squared. It's 9 plus 6a plus a squared. Now finally it says what is the range of f. So that is a set notation. So you'd write this. And my first one was 0, 9, 4, 3, 6.25, 4/9, a squared, and 9 plus 6a plus a squared. Okay, This would be the range if we were speaking of these only being our domain. If our domain was just 0, 3, -2, square root of 3, -2.5, 2/3, a, and 3 plus a, then this would be our range. But here it says where x is the set of all real numbers. So that means I can plug all real numbers in and square them all. Okay, so my range in that case is the set of all real numbers that are greater than or equal to 0. And the way I could write that is 0, comma, 1, comma. No, it wouldn't just be integers. So how can we, what is a number called on the number line that is 0 and greater? They're integers, but they're not the non-negative integers. So that's probably the easiest way to say this. Non-negative. Not just integers either, rational numbers. Non-negative rational numbers. All right. And now that I'm thinking about this, are we always going to get rational numbers? Okay, so I would not agree with this. And whenever you're doing something, think about what your answer is and if there is anything that would make that not true. So I thought of this while I was saying rational. What if I had the square root of pi? That's a real number. And if I square that, I get pi. Pi is not rational. So they can't just be rational. So the best way to say this is all real numbers greater than or equal to 0. Okay, all real numbers greater than or equal to 0. Let's just leave it at that. Okay, page 3. What subset of the real numbers could be used as the domain of the squaring function to create a range with the same output values as the sequence of square numbers 1, 4, 9, 16, 25, ... meaning going on and on from lesson 9. Okay, so, let x, capital X, be the set of non-zero integers. Both the set of non-zero integers and the set of positive integers can both be domains for the squaring function. Or how about we had something like this? Suppose I tried to find something, what's the square root of these? So I could say, well, the domain could be 1. -2. Isn't -2 squared 4? 3, and then I can alternate positive, negative, -4, 5, ... Could that be a domain for this range? Okay, so it could be negatives. We can have negatives in the domain, but we can't have negatives in the range because when you square something, it's never negative. Okay, exercise 3. Recall that an equation can be either true or false using the function defined by f being the set 0, 1, 2, 3, 4, 5 mapped to 1, 2, 4, 8, 16, 32 such that x is getting mapped to 2 to the power of x. Determine whether the equation f of x equals 2 to the x is true or false for each in the domain of f. Okay, so 1, is the equation f of x equal to 2 to the x true or false? So if I take 0, here's the first, they did the first one for us. Substitute 0 into the equation, which is this one right here. Substitute 0 into that would give us f of 0 equals 2 to the 0, 1 equals 2 to the 0. The 1 on the left side comes from the definition of f, and the value of 2 to the 0 is also 1, so the equation is true. Okay, so now we're going to substitute one into the equation. So it's f of 1 equals 2 to the 1. My equal sign snapped there. Equals 2 to the 1. So f of 1 equals 2. Because 2 to the 1 is 2. So if f of 1 equals 2 to the 1, then f of 1 equals 2. So if we look up here, what is happening here is this here, it mapped 0, plugging 0 in and getting us 1. That's why that is true. Now we plugged in 1, and we got 2. So that is true. Let me switch back to green for that. That is true. Okay? And then we keep doing that. Now we're going to substitute 2 into the equation. So we would have f of 2 equals 2 to the 2, which equals 2 squared, or 4. And look up here and see that 2 gets mapped to 4. So that is true. Okay, and moving along, now we're going to go on to the next one. Now we're going to substitute 3 into the equation. So we have f of 3 equals 2 cubed. That equal sign just keeps snapping there. Sorry about that. So this is 2 cubed, which is 2 times 2 is 4, which 4 times 2 is 8. And then when I look up at my mapping, the 3 got mapped to 8. So that is also true. And we continue. F of 4, substituting 4 into this equation, we get f of 4 equals 2 to the 4th power, which equals 2 times 2 times 2 times 2, which is 16. And then when I look up at my mapping, 4 got mapped to 16. So that is true. And then the last time, substitute 5 into the equation, and we get f of 5 equals 2 to the 5th power, which equals 2 times 2 times 2 times 2 times 2, 5 times, which is 32. And then when I go up and look at my mapping, 5 got mapped to 32 in the range, and therefore this is also true. Okay, on to page 4, and it says, if the domain of f were extended to all real numbers, would the equation still be true for each x in the domain of f? Explain your thinking. The answer is yes. Since f maps each x onto 2 to the x, and we agreed to substitute and evaluate the expression to determine the range value for each x in the domain, the equation will always be true for every real number x. Okay, exercise 4 is going to be a little tricky. It says write 3 different polynomial functions such that f of 3 equals 2. Well, if I wanted my equation to be linear, let's start with a linear equation, and I said f of x equals mx plus b. Okay, and we want it to be f of 3. In other words, we want x to be 3. So that would mean some m times 3 plus some value b has to equal 2. So I will write f of 3, I'll replace it with 2 because f of 3 equals 2. I want 2 to equal m3 plus b. Well, there's 2 ways we can do this. We can just make up a value for m, or we can make up a value for b and solve for the other. I'm just going to let m equal 2 and actually let's make it 4 so it's not the same as this. So I'm just going to make this up, and I'm going to say 4 times 3 plus b equals 2. And then when I do that multiplication, I get 12 plus b equals 2. Okay, so all you have to do is make up an m or choose a b and solve for the other. So now to get b by itself, I subtract 12. And when I subtract 12 from both sides, I get negative 10 equals b. Okay, so finally I have the equation. So I would say f of x equals, and my m was 4. So it would be 4x, and my b was negative 10, minus 10. So when I check that, f of 3 would be 4 times 3, which is 12, minus 10, which does equal 2. Okay? So there is a linear equation. That would be true when that would make f of 3 equal to 2. Okay? So that's just one example. Well, how about we did that with a quadratic? So if I said f of 3 equals ax squared plus bx plus c, well, keep in mind these are my x's, so that would be so this would be f of x I should have here, like I did in the first one over here. So here's the quadratic. F of x equals ax squared plus bx plus c. We want f of 3 equals a times 3 squared plus b times 3 plus c. And we want that to equal 2. So this is going to be a 3 squared okay, let me just fix this right here. So we have f of 3 equals a times 3 squared, and so I'm just going to write it in order for now. That's a times 9 plus b times 3, or 3b, plus c. Now, let's not make this difficult. Let's just give a value of a. Let's just have our leading coefficient 1, so it just goes away. So that would mean that 2 equals 9 times our 1a plus 3 times, let's choose 2 for b, for instance, and then just solve for our c. So when I do that, I get 2 equals 9 plus 6 plus some constant. And when I add my like terms, I get 15 plus c equals 2. To get c, I subtract 15 from both sides, and I get negative 13 equals c. So my function is f of x equals, remember I let a equal 1, so I don't have to write 1x squared. I can just write x squared. And I let my b equal 2, so that's plus 2x minus 13. So there is an equation that if I substitute in 3, I will get 2. 3 squared is 9, plus 3 times 2 is 6. 9 plus 6 is 15. 15 minus 13 equals 2. Okay, so you get the idea. And then we could do another one. So let me just erase this now. And I will do one more. And how about we do another quadratic? And this time I won't have a middle term of b. So let's just say f of x equals ax squared plus some constant. So we'll just call it b, going in alphabetical order. Okay, so f of x equals ax squared plus b. No linear term in this. I want f of 3, which means sum a times 3 squared plus b. And I want that to equal 2. So f of 3 equals 2. And 3 squared is 9. So I get 9a plus b equals 2. Now I can just choose a value for a or b, and it doesn't matter. Either one. I will choose, let's just use 2 for a. So 2 equals 9 times 2 plus b. Well, that would be 18 plus b equals 2. Subtract 18, and I get negative 16 equals b. Okay, so my function would be f of x equals, okay, I let my a equal 2, so it's 2x squared, and my b is minus 16. So if I plug 3 in, I get 3 squared, which is 9. 9 times 2 is 18. 18 minus 16 equals 2. So that is also a function where if I substitute in 3, I will get an answer of 2. All right, exercise 5 says the domain and range of this function are not specified. Evaluate the function for several values of x. What subset of the real numbers would represent the domain of this function? What subset of real numbers would represent its range? Okay, so I could start off with a table, x comma y, and just choose values. Let's start at negative 2. And if I plug in a negative 2, that means f of negative 2 equals the square root of negative 2 minus 2. Well, that equals the square root of negative 4, and the square root of negative 4 equals the square root of negative 1 times the square root of 4. And the square root of 4 is 2, and the square root of negative 1 is I. And you're like, what? Okay, well, if I go into my calculator, let me just show you something. Okay, so here's my calculator, and I had the square root of negative 4. So if I do square root negative 4 and hit enter, it says error, non-real answer. Quit or go back to it and fix it. And if you go to it, brings you back here. Okay, so that is a non-real answer. I called it I. That's the imaginary unit. That is not, you're not there yet. So I'll just leave it at that. That is not real. We cannot take the square root of a negative number and get a real number. So I'm just going to do this for now. All right, so what can I do that will give me a value that is? So let me just erase this and try another. Now if I did negative 1, negative 1 minus 2 is negative 3, it's still negative. 0 minus 2 is negative 2, 1 minus 2 is negative 1. Well, what will make this 0? If you just think of finding where that equals 0, just take what's under the radical, which is called a radicand, and set it equal to 0 and solve. And in order to solve for x, I add 2 to both sides. I didn't mean to put the equal sign there. Add 2 to both sides, and these get canceled, and I get x equals 2. So if I let x equal 2, then that would be f of 2 equals the square root of 2 minus 2, which is the square root of 0, which is 0. Okay, I can do that. So I can take the square root of 0. Whoops, clear. I can take the square root of 0, and that is 0. Okay? And then when I go to a larger number like 3, then f of 3 would equal the square root of 3 minus 2, which equals the square root of 1, which equals 1. And if I plug in 4, that's f of 4. And that equals the square root of 4 minus 2, which equals the square root of 2. And that's a decimal approximation, so I'll just leave it at square root 2. And f of 5 would be the square root of 3, and f of 6 would be the square root of 4, which is 2, and so on and so on and so on. So the domain and range of this function are not specified. Evaluate the function for several values of x. What subset of the real numbers would represent the domain of this function? Okay, so the domain, what can we conclude from that? Our domain can be the set. Okay, what subset of the real numbers? And the answer is all real numbers greater than or equal to 2. Okay, and and there's our domain. 2 works, and everything greater than 2 will work, but less than 2 gives us imaginary units. The range is real numbers greater than or equal to 0, since the principal square root of a number is always positive. Okay, so the range is what values we can get out of this. These are never going to decrease. As we're increasing our values in this function, the range is going to increase. So 0 is our minimum, and it's going to start growing from there. So I will never get a value less than 0 because 2 is the lowest value from my domain. So the range is the set of all real numbers greater than or equal to 0. Okay, and now I'm going to introduce something else to you, another way to write this. Instead of writing all this, we can just say, hello, I changed colors. You all saw that, I know you did. Hello. Okay, so T, that's better. D colon, the set of all X, and this weird looking E just means X's that are in some range, and a bracket means we're including a value, we're including 2, and we're going to infinity, and we use an open parentheses for infinities because it goes on forever and ever. Infinity is not an actual number. I can't use a bracket. All right, and then the range would be the set of all X in the area on the number line from 0, and that goes to positive infinity. And it includes 0, so the bracket means equals. So this is the shorthand way of writing the domain and range. X such that it is in this set from 2 to infinity. X such that it is in the set from 0 to infinity. I forgot my f of. That's not X. Range is Y. Okay. All right. So that's why I always read my answers after and make sure that makes sense. So I don't want to put X there. I want to put f of X. And Y is f of X. All right. That is the end of lesson 10. Review the lesson summary and go do your problem set.